Unequal current sharing in parallel feeders can arise from several factors, leading to some cables carrying more current than others. This can result in overloading, overheating, and potential damage to the electrical system. It's important to systematically investigate and address the root causes of this issue. Firstly, verify that the cables are actually the same length. Even if they appear identical, small differences in length can significantly affect impedance and current distribution. Use a tape measure or other accurate measuring device to confirm the lengths of all parallel cables. Secondly, consider cable quality differences. Although the cables may have come from the same reel, slight variations in manufacturing can impact their current carrying capacity. Manufacturing tolerances or subtle differences in conductor material can lead to variations in resistance and impedance. Connection issues are another common cause of unequal current sharing. Loose, corroded, or poorly made connections introduce additional resistance, forcing more current through other parallel paths. Carefully inspect all connections at both ends of the cables, ensuring they are clean, tight, and properly made. Conduit fill can also play a role. If the cables are installed in a conduit or duct bank that is too full, it can restrict airflow and cause the cables to overheat, reducing their current carrying capacity. Check the conduit fill ratio to ensure it complies with the National Electrical Code (NEC) requirements. Ambient temperature is another factor to consider. The surrounding temperature can significantly affect the ampacity of cables. If the cables are located in a hot environment, their current carrying capacity will be reduced. Uneven distribution of current among the cables in each phase can also lead to overloading on some cables and reduced capacity on others. This is known as cable loading imbalances. To address these issues, begin by recalculating cable ampacity. Use the NEC tables or other industry standards to recalculate the ampacity of the cables based on their actual length, conductor size, and surrounding conditions. The NEC provides guidelines for adjusting ampacity based on temperature and the number of conductors in a raceway. Verify cable installation. Inspect the installation to ensure proper cable spacing, secure connections, and appropriate conduit fill, referring to the NEC for specific requirements. Measure cable resistance. Use a micro-ohmmeter to measure the resistance of each cable and compare it to the expected value. This will help identify any potential quality issues or damaged conductors. Consider load balancing. If there is a significant imbalance in the load distribution among the phases, consider adding more cables or redistributing the load to balance the currents. This can be achieved through careful circuit design and load management. If the existing cables are insufficient for the load, consider upgrading them to a larger size or adding additional conduits to improve airflow. This may involve replacing the existing cables with larger conductors or installing additional parallel runs. If the surrounding temperature is excessive, consider measures to reduce it, such as installing fans or air conditioning. This will help improve the ampacity of the cables and prevent overheating. Now let's delve deeper into each of these aspects. Regarding unequal cable lengths, even seemingly small differences can have a noticeable impact. For example, if one cable is 1% longer than the others, it will have a slightly higher impedance, causing it to carry less current. Use a high-quality measuring tape and carefully measure each cable individually. Ensure that the measurements are taken under similar tension to avoid errors. Cable quality differences are subtle but real. Manufacturing variations can lead to differences in conductor purity, insulation thickness, and overall construction. These variations can affect the cable's resistance and its ability to dissipate heat. While visual inspection may not reveal these differences, resistance measurements can help identify anomalies. Loose or corroded connections can dramatically increase resistance and create hotspots. These hotspots can lead to further degradation of the connection and potentially cause a fire. When inspecting connections, use appropriate tools to ensure they are properly tightened. Consider using antioxidant compounds to prevent corrosion, especially in humid environments. The NEC specifies maximum conduit fill ratios to prevent overheating. Exceeding these ratios restricts airflow and reduces the cable's ability to dissipate heat. When calculating conduit fill, consider the cross-sectional area of all cables and conductors within the conduit. The ambient temperature surrounding the cables is a critical factor in determining their ampacity. The NEC provides ampacity correction factors for various ambient temperatures. For example, if the ambient temperature is consistently high, you may need to direct the cable's ampacity significantly. Load imbalances between phases can exacerbate the unequal current sharing problem. Unevenly distributed single-phase loads can cause some cables to carry significantly more current than others. Consider redistributing single-phase loads to balance the current draw across all three phases. When recalculating cable ampacity, be sure to consider all relevant factors, including ambient temperature, conduit fill, conductor type, and insulation rating. The NEC provides detailed tables and formulas for calculating ampacity under various conditions. When inspecting cable installation, pay close attention to cable spacing. Adequate spacing between cables allows for better airflow and heat dissipation. Use cable ties or other means to maintain proper spacing. Measuring cable resistance requires a microohmmeter, which is a specialized instrument designed to measure very low resistances accurately. Compare the measured resistance values to the expected values based on the cable's length, conductor size, and material. If there is a significant imbalance in load distribution, consider using load balancing transformers or other techniques to improve the balance. Load balancing transformers can help distribute the load more evenly across all three phases. Upgrading cables or adding conduits can be a costly but effective solution. If the existing cables are consistently overloaded, it may be necessary to replace them with larger conductors or install additional parallel runs. Reducing ambient temperature can be achieved through various means, such as improving ventilation, installing fans, or using air conditioning. Consider the cost and effectiveness of each option when deciding on the best approach. Remember that addressing unequal current sharing in parallel feeders requires a systematic approach, starting with a thorough investigation of potential causes and followed by appropriate corrective actions. Consult with a qualified electrical engineer or electrician to ensure that all work is performed safely and in compliance with the NEC and other applicable codes and standards. Furthermore, documenting your findings and the steps you take to resolve the issue is crucial. This documentation can be valuable for future troubleshooting and maintenance. Maintaining accurate records of cable lengths, resistance measurements, and load distributions can help you identify trends and potential problems early on. Consider using thermal imaging to identify hotspots in connections or along cable runs. Thermal imaging cameras can detect temperature differences that may not be visible to the naked eye, allowing you to identify potential problems before they become serious. Finally, it's important to emphasize the importance of regular maintenance and inspection of parallel feeder systems. Periodic inspections can help identify potential problems before they lead to failures or safety hazards. Implement a preventative maintenance program that includes regular inspections of connections, cable insulation, and overall system performance. Consider using online monitoring systems to continuously monitor current levels in each cable. These systems can provide early warnings of imbalances or overloads, allowing you to take corrective action before problems escalate. By taking a proactive approach to maintenance and monitoring, you can ensure the long-term reliability and safety of your parallel feeder system. In summary, addressing unequal current sharing requires a combination of careful investigation, accurate measurements, and appropriate corrective actions. By understanding the potential causes of the problem and implementing a comprehensive maintenance program, you can ensure the safe and reliable operation of your electrical system. Remember to always consult with qualified professionals and adhere to all applicable codes and standards. And always prioritize safety when working with electrical systems.